Oh. Am I on? Hello, hello.
There you go.
Hello from Long Life. Hello, my friends. How kind of you to come. Oh, there we go. Doesn't believe me. Trying to get to my first slide. There it is. So this is an introduction to the real power of the energy in biomass. And many of my favorite words have all been hijacked in various ways, or let me just say they've been repurposed. And so biomass is something I've been working with for more than 30 years as a high temperature chemist, working with thermal conversion of biomass. And so how was I to know that we would discover CBD? And CBD would be our new lucrative distraction. And so we are working on a project of pelletizing spent biomass from an extractor, and we're going to turn that the energy in that biomass into heat and power. So we're looking at the power and the energy in biomass. And so true biomass and its kissing cousin, CBD, is the new untapped treasure. So biomass is produced by photosynthesis. CO2 and water are turned into solid biomass. Burning of biomass returns only recent CO2 back into the atmosphere. Burning fossil fuels releases ancient CO2 into our atmosphere. So char-making biomass systems replacing fossil fuels can be the key to the only truly carbon negative fuel cycle known to humankind. And so that is the center of this project. Let's look at materials from wood all the way to bean straw. And I look at the carbon, hydrogen, and oxygen composition, and they're amazingly identical. So on a moisture and ash-free basis, all biomass is remarkably similar, around 8,000 BTUs a pound. This triangle has got hydrogen at the top and oxygen at the right corner and carbon at the left. That lets us see what is the solid, liquid, and gaseous the materials. Now those are the three ways that matter occurs. People ask me, what's the fuel of the future? And I say, well, what's the fuel of the present? Liquid. And then there's an increasing amount of gaseous fuel. And then my work is with solid fuels, and I tell people that wood will not burn. It's only the fumes from burning wood that burns. You see down on the left, you got chars and coals. There's some up higher, you have biomass, these little round circles right below where it says biomass. And then you got liquid fuels with a higher hydrogen content. Then you got methane up on the top on the left. That's gaseous. And then that center line going all the way up to the top, that's everything between there and the line to its right is gaseous fuels. Carbon monoxide and hydrogen both have the same energy value. See, carbon monoxide is the slowest burning gas, hydrogen is the fastest. And over there on the right, you have water vapor, H2O, and CO2. Those are combustion products. We use those to put out fires. So there's about 300 BTUs a cubic foot is the energy value of both hydrogen and carbon monoxide. So people ask about the scalability of biomass fuel systems. You know, how big and small can they be? Can we do this on a scale that can make a difference? So the simplest demonstration of pyrolysis and gasification can be viewed in a match. So our scale is from matchstick to megawatts. There's a lot of work to do there, but you see that a match starts out as white wood, and the heat of the flame indicates that pyrolysis is underway. You get a visible flame in a match as the flame progresses toward your finger. What's really happening is you see that pyrolysis, the charring, proceeds from where it's hot at the surface down to the center of the wood. And as long as it's pyrolyzing, it's giving off pyrolysis gases that's actually shielding. It prevents the oxygen and the air from touching the charcoal. It's only after the flame is finished that you see the tip of the match will be able to glow. So the glowing is evidence that the charcoal is reacting with air. The temperatures go all the way up to about 1500 degrees C and in the brightest glowing part. And then up above that, if your flame is not too big, you'll have no soot, and it drops down to around 400 C. So the first step in pyrolysis is that heat separates biomass into roughly thirds: condensables, char, and gases. It's the condensables that make cigarette smoke visible. Biomass will rot, but char does not rot. It stays in the soil for thousands of years. Ask any archaeologist, maybe millions of years. But so the solid carbon gives us an opportunity to lengthen the amount of time that the carbon is out of the atmosphere. So it's a great opportunity to capture and reduce greenhouse gas. If the char is not burned, then it's not in the atmosphere. And each pound of carbon as a solid is 3.6 pounds of CO2 that's not in the atmosphere. This is one of the first improvements that was done in gasification. This is our straight tube downdraft gasifier. You find air is coming in through the top. It passes through non-burning biomass fuel, and when it meets the flame front, you'll see the temperature rises really rapidly, and pyrolysis is taking place in this area. That's roughly 3 fuel particle diameters. And then the hot gases, as you see to the right, there's water vapor and steam and temperature all climb up really high, and then the CO2 and hydrogen react with the char and make the hydrogen and carbon monoxide gases, which are our fuels. And where did the oxygen in our atmosphere come from? Oxygen is the result of photosynthesis and the accumulation of unburnt biomass. That actually says there is a tremendous amount of fossil fuel in the crust of the earth. 20% of our air is oxygen. So the amount of fossil fuel within the earth can be estimated by the total oxygen in the atmosphere. 20% of 14 psi times the surface area of the earth adjusted for molecular weight. Have fun, you figure it. Fossil fuels bring or spew ancient carbon into the atmosphere. Ancient carbon from burning fossil fuels increases the CO2 greenhouse gas inventory in our atmosphere. The burning of biomass simply returns recent CO2 into the atmosphere. That's carbon neutral. Hundreds of gallons of gasoline releases a ton of CO2 greenhouse gas. Each 100 gallons of petroleum prevented is 1 ton less of CO2 greenhouse gas in our Earth's atmosphere. Here's the chemistry of what's going on. Carbon combustion, carbon plus oxygen gives us CO2 and heat. Hot CO2 reacts with carbon to give us 2 carbon monoxides, which are fuel gases. They're burnable. And the water gas reduction is water vapor, superheated steam, and carbon reacts to give us a hydrogen and a carbon monoxide. A little bit of hydrogen goes a long ways in improving the burning characteristics in any engine. So wood, if it's fully gasified, can prevent fossil fuel CO2. So the benefit of this is substantial. Each pound of dry biomass into the gasifier hopper can be a pound of CO2 greenhouse gas prevented.